Hey physics students, Mr. Magaluk here with a lesson on the meaning of slope for velocity versus time graphs. So we've been talking about graphing and we've been working with position versus time graphs. So graphing where an object is on some sort of axes and plotting those points as that object moves along. Well, now we're going to be investigating velocity versus time graphs. So we're going to be taking data, our velocity at various points in time, and we're plotting that on a graph. And so I have two examples of graphs that I've already made. So in this example, this is an object that is moving at 10 meters per second. So at second 1, it's moving at 10 meters per second. At second 2, second 3, second 4, second 5, it's moving at 10 meters per second. Well, if an object is moving at 10 meters per second, and it just stays moving at that rate, we know that that object is not changing its velocity, it's staying the same, therefore we have a constant velocity. And so our velocity just stays the same. We have a completely horizontal line. Now in this case, we have an object here. It starts at 0 meters per second. And then at second 1, it's at 5. And second 2, it's at 10. Second 3, it's at 15. Second 4, it's at 20. Second 5, it's at 25 meters per second. So it's getting faster and faster with time. And when we plot that data, we have a graph that is a straight line going up. However, we learned in the previous video about meaning of slope for position versus time. And so we said that anytime we have a straight line for a position versus time graph, we're at constant velocity. However, now we're looking at a velocity versus time graph. And so this isn't talking about our position, it's actually talking about our velocity. And so the meaning for the slopes of these are different. We're talking about a different quantity, and I'll explain that in just a second. So moving over here, the slope of a velocity versus time graph reveals information about what of an object? Well, let's dig into that a little bit. Slope is rise over run. So it's the amount of height I gain on the y-axis divided by the length I move across on the x-axis. So slope is rise divided by run. So on this graph, we have our rise, which is delta y, or change in my height, divided by change in x. Okay? So our y here is measured in units of meters per second. So slope of v versus t graph equals rise divided by run, which is my change in y, which is actually just my change in velocity, so change in velocity, divided by our change in x, which is our change in time. Well, y'all have learned this. What is change in velocity divided by change in time? Well, if you said acceleration, you're absolutely correct. So this is why the slope of a velocity versus time graph is, in fact, the acceleration of an object. It's because the slope calculates our acceleration for us. And so slope of a velocity versus time graph is, in fact, or reveals information about the acceleration of an object. So I want to talk about a few different examples of different graphs here and just kind of walk through and explain what we are seeing or what we should be seeing with these graphs. But before we get there, let's talk about this graph. The slope of that graph, and this isn't something we talked about with position versus time graphs, but the slope of this is 0 because it's totally horizontal. I'm not gaining anything up or down. It is just completely flat. And so we know that the slope of this graph is acceleration. And so here we just said this was constant velocity, and which checks out because our acceleration is 0, meaning we have a constant velocity. We're staying at 10 meters per second every single second of the journey. Versus over here, we're gaining 5 meters per second every single second. And so our acceleration in this case over here is 5 meters per second per second. Okay, so let's talk about positive versus negative velocity. So how do we know if, by just looking at a velocity versus time graph, if an object has positive velocity or negative velocity? Well, I'll tell you right now, if the velocity is above the x-axis, if the line is above the x-axis, we are in the positive velocity region. So our velocity is positive when we're above the x-axis. When we're below the x-axis, we are in the negative velocity region, and we will have negative velocity. Now these graphs look a little bit different. So this one up top, we have an angle. So we'll get to whether it's speeding up or slowing down in just a minute. But no matter what this line is doing, if the velocity, meaning this line, is above the x-axis, well, we have positive velocity. If the line is below the x-axis, we have negative velocity. All right, so now how do we tell by looking at a velocity versus time graph whether or not the object is speeding up or slowing down? We already talked, we know it's constant velocity when the slope is totally horizontal. So whenever our velocity versus time graphs look like this, we know for a fact that it's constant velocity and therefore an acceleration of 0. But for these, how do we know if it's speeding up or slowing down? Well, we know that our x-axis represents the 0 y-axis. So anytime we're right on this line, we know our velocity is 0. Now, this line right here starts at 3 and goes up to 9. So we're starting with this value and we're going up to a positive 9 for our velocity. So I would say this is speeding up because we're going from the x-axis up and away from the x-axis, and our numbers are getting bigger and bigger. So we have a positive acceleration, and we're speeding up here. Now in this case, we're starting far up top, so we're starting with a big velocity, the 9, and we're going towards the x-axis to where that velocity is 0. So in this case, I'm actually slowing down. I'm going from a high velocity to a low velocity. Now these two examples here, they are in the underside, or in the negative region of the graph, in the y-axis. And however, we're starting at negative 3 meters per second, and we're going to negative 9 meters per second. Can I be going slower than 0? No, we talked about this in a previous video, that I can't be going any slower than 0. A negative velocity, remember, just means that we are moving in the negative direction, or the leftward direction, or the downwards direction. And so my velocity starts from negative 3, goes to negative 9, so I'm actually speeding up in this graph. I'm going close to the x-axis and going far away from it. Now this example, I start at negative 9, and we get closer to the x-axis at -3. And so here we're going far away from the x-axis, closer to it, and we're getting closer to this axis. So in this example right here, this object is slowing down. All right? So just to recap this, anytime our velocity versus time graph goes farther away from the x-axis, it's speeding up. Anytime our velocity versus time graph gets closer to the x-axis, we are slowing down. All right, so here's a little challenge question for you, just a quick quiz to see if you can think about what this graph might mean. So go ahead and pause your video here. Take a look at this velocity versus time graph. This is the positive region up here. This is the negative region down here. I want you to think and see if you can describe the motion of this object. Go ahead and pause your video. Take a guess. All right, now that you've guessed mentally what this object is doing, I will go ahead and explain. This object, and let me just go ahead and describe or show you what this object is doing, and then we'll talk about it. So let's say this direction is positive, this direction behind me is negative. So, all right, demonstrating this motion. I think I ran off the screen. Give me a second. All right. I'm going to go out of the screen. I'm going fast. I slow down and then turn around and speed back up. So this motion represents an object moving fast in the positive direction. They slow down. They reach a velocity of 0 because they've crossed this axis, and then the object turns around and moves in the negative direction and starts to speed up. Because now we hit this line, we reached a 0 velocity, and now we're moving away from the x-axis with bigger and bigger numbers, and so we're going to be speeding up in the negative direction. Hopefully this brings some clarity to velocity versus time graphs. Thank you all for watching this video. As always, if you have any questions or concerns, please reach out to me. I'm more than happy to answer anything. Thanks for watching.